Good day, students. Welcome to part 7 of the Algebra 2 CST review. We're going to be going over questions 77 through 83 in this installment, and it's focusing mainly on combinatorics, okay, permutation, combination, uh, the um, the binomial theorem, Pascal's triangle, all this cool stuff. Anyway, remember that you can get a copy of this document at microsoft.com/testprep. Let's take a look at question 77. All right. So in question 77, it says Abelardo wants to create several different 7-character screen names. He wants to use the arrangements of the first 3 letters of his first name, ABE, followed by arrangements of 4 digits in 1984, of the year of his birth. How many different screen names can he create this way? All right, I'm going to show you 2 ways of setting up this problem. The first one is by creating placeholders. So we're going to have total number of 7 characters. So the first 3, let me put that in green. 1, 2, 3 are going to be, we're going to formulate these using the letters A, B, E. Okay? And then the last 4, 1, 2, 3, 4, we're going to be we're going to be selecting from 1984. All right. So for the first 3, in ABE, how many letters do we have? For ABE, we have 3 letters, right? So in the first spot, we have 3 choices. After we select 1 letter for the first spot, what do we have for the next spot? We have 2 choices, okay? And then if we select another one, how many do we have left? 1. All right, so these are the number of ways you can select 3. You can arrange 3 letters from ABE, okay? All right, and then for 1984, we're going to be selecting 1 digit from this number to fill the first spot, the second spot, and then the third spot, and then the fourth spot, okay? So we select 1 digit from here. How many ways can we select 1 digit from 1984? You have 4 candidates here, so we have 4 digits to be selected for the first spot. For the next spot, since we've taken out 1, how many choices do we have left? We have 3, okay? Times 3. And then for the next choice, we've taken out 2, we're left with 2. It goes down to 2. And then lastly, we just have 1 left, okay? So if you multiply all of this together, that will basically give us the answer. Another way we can do this is by using combination or permutation. So the question here is, what are we going to use in this case? Are we going to use permutation or combination? Remember, another word for permutation is to arrange. Okay, so anytime you see talk about arrangement or placement, or anything that has to do with position, you think about permutation or order. Okay, the keyword is order. So permute is how are you placing, arranging, positioning, or ordering elements from a set. Okay, so see the keyword here, arrangements. That should tell you automatically that we're working with permutation here. So if you know your permutation formulas, you can simply use that in this problem. So if I wanted to use my permutation formula, I will go for the first 3 choices. I have out of 3, I am selecting 3, so 3p3 times, for the next one, out of 4, I'm arranging 4 elements, okay? And then the formula for permutation, let me put that on the side here. The formula for permutation, NPR, is basically n factorial over n minus r factorial, okay? So if I apply this to this problem, 3 arrange 3 is going to be 3 factorial over 3 minus 3 factorial, which equals 3 factorial over 0 factorial, which equals 3 times 2 times 1. 0 factorial by definition is 1, okay? And then 4, the number of ways you can arrange 4 elements, selecting 4 at a time. Using this formula, we're going to have 4 factorial over 4 minus 4 factorial, okay? In this case, note that the first letter is the N, this is the N here, and then this is the R, okay? So we're going to have 4 factorial over 0 factorial, which equals 4 times 3 times 2 times 1 over 1. If I multiply these two together, what do I get? So 3p3 times 4p4 is equal to 3 times 2 times 1 times 4 times 3 times 2 times 1. Guess what? This is exactly what we had in our setup up here. Okay? So you can use this method just using placeholders, or you can use the permutation formula. Just, you get the same answer. Okay? So if we multiply these three numbers, what do we get? So let's multiply them since you're the same. 3 times 2 is 6. Let's forget about the 1. 4 times 3 is 12. 12 times 2 is 24. 6 times 24 is 144. Okay? So your answer is option B. So there you have it. So remember, anytime you're dealing with arrangements, is permutation. Okay? All right. Now let's go ahead and take a look at the next question, question 78. All right. It says a locomotive train is made up of a train is made up of a locomotive, 7 different cars, and a caboose. If the locomotive must be first and the caboose must be last, how many different ways can the train be ordered? You see another word there? That word ordered, what does that mean? That means permutation again. All right? Ordering, placement, permutation, all those stuff, they mean the same thing, okay? All right, so for 78, I'm going to do it the first way I showed you, and then I can also show you how I could do it with permutation. So we have a locomotive takes the first spot, and then we have 7 different cars. All right? So this is a locomotive, and then we have 7 different cars. 1, 2, 3, 4, 5, 6, 7, and then the caboose takes the last spot. Okay? Now, we're told that the locomotive must be first. So this spot is locked. We don't have any, this doesn't move, it's fixed. Okay? And then the caboose must be last, so this spot is fixed. So you don't get to move it around. All right? So if we lock in the first and last spot, what we're ordering is the 7 cars between them. So we're in actuality just ordering 7 cars. So if you're ordering 7 cars, how many cars can you possibly choose to place in the first spot? Since you have 7 cars, you have 7. Okay? 1 is taken. How many do you have left to fill the second spot? Since 1 is taken, you're left with 6, 5, 4, 3, 2, and then 1. Okay? So if I multiply all these numbers together, that'll basically give me my answer. Another way to look at this is it's permutation because we're ordering. So 7p7. Using the permutation formula, let me write it up here again. If you have, let me write it in red. If you have npr, is basically n factorial over n minus r factorial. Okay, this is a permutation formula. That additional r factorial there takes away the order and it becomes combination. Okay, but this is permutation, so that's all you have. So here we're going to have 7 factorial over 7 minus 7 factorial, which is 7 factorial over 0 factorial, which is 7 times 6 times 5, 4, 3, 2, 1. 0 factorial is just 1, so we just forget about it. So you see that this is our, in fact, our answer. All right? So let's go ahead and multiply it out, and that will give us our answer. 7 times 6 times 5 times 4 times 3 times 2 times 1. You multiply the first two, that gives me 42. 5 times 4 is 20. 3 times 2 is 6. Okay, so what is the easiest way to multiply these numbers? How about we multiply these first two first? 42 times 20, 42 times 20, you just double this and add a 0 behind it. So it's 840. 840 times 6 is simply 800 times 40, right? So if you multiply 800 times 6, you get 4800, and 40 times 6, you get 240. And then when you multiply them together, you're going to have, let's see, 0, 4, 8 plus 2, 10, 0 carry 1, 5040 different ways that you can arrange the cars. Okay, remember, you're just arranging the cars, the caboose, and the locomotive are fixed. All right? So that's basically how it turns out. Anyway, your answer is option A. All right. Let's take a look at question 79. It says there are 12 candidates in a city election. The winner will be the mayor and the runner-up will be the vice mayor. How many different combinations of mayor and vice mayor are possible? Okay, so is this a permutation or combination problem? Don't let this word combination throw you off, okay? That's a distractor. What is happening here? Are they just being selected as a group or are they being placed into positions here? You notice that a mayor is a position and the vice mayor is also a position. So what are we doing here is we're placing people from the 12 into positions, two positions. Okay? So let's see. What does placing mean? Placing basically means permutation. Okay? Placement means permutation. So that's the whole idea. All right? All right, so I'm going to show you two ways of doing this. I will you do this using the easy way, and then I'll show you using the permutation formula, okay? So out of 12 people, you're placing two people, okay? So out of the 12, how many choices do I have for the mayor position? Out of the 12, I have 12 people that can fit into this position, right? So 12 choices. Guess what? This spot has been taken. One person is taken out of here. I'm left with 11. Now, how many people can be selected to fill? How many choices do I have to select someone to fill the vice mayor position? I'm left with 11. So 12 times 11 will give us our answer. Okay? All right, that's not easy to work out, 12 times 11. We can figure that out in a minute. But let me show you the same process using the permutation formula. Remember, we're placing people, that's why we have the permutation, okay? So the permutation formula is NPR equals n factorial over n minus r factorial, right? In this case, n is 12 and r is 2. We're selecting two people, so how many ways can you place two people, select two people to be placed from a set of 12. Okay, so we're placing two people from a set of 12. How many ways can you do that is a question. So this is your n and this is r. So we have 12 factorial over 12 minus 2 factorial. Okay, let's work this out. We have 12 factorial over 10 factorial. Now, how do you do this? You just break down the numerator until you get to a factorial expression that matches the denominator, right? So I'm going to go 12 times 11 times 10 factorial. You stop right there because it matches the 10 factorial on the bottom. Since we have a match, guess what? We can just cancel these two out. And what are we left with? We're left with 12 times 11. That's exactly what we had up here when we use the other method, okay? So what is 12 times 11? 12 times 11 is 132. You can do the multiplication to verify. So our answer is option letter C. All right. Okay, let's take a look at question number 80. Question 80 says, Teresa and Julia are Teresa and Julia are among 10 students who have applied for a trip to Washington, D.C. Two students from the group will be selected at random for the trip. What is the probability that Teresa and Julia will be the two students selected? Okay, so we're making two selections here. Obviously, we can't repeat because there's only one Teresa and one Julie. They're different, they're unique individuals. So let's see, how do we do this? Remember, probability of an event is basically uh, possible outcomes over total, okay, over total. Okay, so that's a probability formula. So in this case, we're going to be looking at we're selecting two students, Teresa and Julia. It doesn't really matter what the order is. It could be Julia first and Teresa second, or Teresa first and Julia second, so it doesn't really matter. Okay, so in this case, probability of Teresa and Julia is what? What is that going to be? So we're going to do the probability of Teresa first. what are the chances of selecting Teresa out of 10 students? Um, we're we're selecting to be successful, we're selecting only 2 students, right? So possible outcomes is 2, and what is the total number of students that there are? 10. Okay, so I'm picking only 2 students, and what is the probability that is going to be Teresa's? So it's going to be 2 out of 10. All right? All right, so, and then for the next selection, we are going to be, it could be Julia or it could be Teresa, but if we're selecting only 2 people, one person has already been selected. So how many choices do we have for the next pool? If we've selected Teresa, we're left with just Julia, one person, or we selected Julia, we're just left with Teresa. So after one person has been selected, and we're selecting only 2, we have a choice of picking one out of the remaining 9. Okay? So this is a probability of selecting Teresa and then Julia. Basically 2 people out of a set of 10 without repetition. Okay? So we can just simplify this, multiply it across. We have 2 over 90. And I can divide the numerator by 2 and divide the denominator by 2. And that reduces into 1 over 45. So our answer is option A. All right, let's move on to question number 81. Question 81, we are to expand 31y to the 4th. We can do this in 2 different ways. 81 is 3y minus 1 to the 4th. You can follow this out 4 times if you have energy, or you can use Pascal's triangle, okay? Pascal's triangle, we're going to go to the 4th row, and then it tells us the coefficient, and then we're just basically going to establish a pattern of increasing and decreasing degrees, all right? So let's go ahead and draw our Pascal's triangle. So this is row 0. The row 0 is just 1 because anything to the 0th power is 1. Row 1 is 1, 1. So this is the first power. And then you construct row 2, 1, add 1 plus 1, 2, 1. We're going to row 4, right? 1, 3, 3, 1. You get this 3 by adding these 2, and you add these 2, you get a 3. This is row 3, the coefficients of the expansion. And then row 4, you have 1, 3 plus 3, 4, 3 plus 1, 3, 3 plus 1, 4, 3 plus 3, 6, 3 plus 1, 4, and then 1. So this is for the 4th power. All right? All right, so what I'm going to do is I'm going to line up these terms on the side, and I use them for the expansion of this binomial, okay? So you have 1, 4, 6, 1, 4, 6, 4, 1. All right, so we have 2 terms here. The first term is going to be 3y, and the second term is going to be negative 1. Okay, so notice what I'm going to do here. I'm going to go 3y, so 1 times 3y. I will start 3y from the 0th power. 3y to the 0. If 3y is 0, that means that negative 1, let me put that in red, negative 1 is going to have the 4th power. So 0 plus 4 is 4. The powers of these two always have to add up to 4. So this is nothing, this has everything. They're splitting this power amongst themselves, okay? So this has none of it, this has all of it. So now we're going to have a power switch taking place here. So the next one is going to be 3y is going to go up. We have 3y to the first, and then 3y to the second, and then 3y to the third, and then times 3y to the fourth. Okay, so this one goes from nothing to everything. And then guess what happens with the negative 1? It goes from everything down to nothing. So it's going to be times negative 1 to the third. All this is be multiplied. And then this one will be times negative 1 to the second. It's going down. And this will be times negative 1 to the first. And then this will be times negative 1 to the 0. All right? So if I multiply all these terms out and I add them down, that will be the expansion of 3y minus 4, 3y minus 1 to the 4th. Okay? All right, so let's work this out. First term, 3y to the 0, anything to the 0th power is just 1. So this is negative 1 to the fourth. Negative raised to an even power is always positive. So you got to remember that. Okay? Negative raised to an even power is always going to be positive because they all pair up. But if you have negative raised to an odd power, it's going to be negative because all your pairs, because you have odd number of pairs and one of the pairs will be left, one negative will be left alone. All the other pairs will form a plus. Okay? So 1 times 1, this is simply going to be 1, positive 1, times positive 1, because negative 1 to the fourth is 1. 1 times 1 is 1. And then this will be 4 times 3y. This 1 gets distributed to both of them. This is still 3y. Negative 1 to the third is odd, so it's going to be times negative 1. Alright? Remember, negative to the odd is negative. If you multiply this out, you get negative 12y. And then for this one, we're going to have 6 times, you distribute this 2 to the 3, it becomes 9. And then when you distribute this square to the y, it becomes 9y squared. So 3y squared is 9y squared, times negative 1 to an even number, which is 2, is just positive 1. And when you multiply this out, 6 times 9 is going to be 59y to the second power. Actually, it's 54. 54. 6 times 9 is 54. 54y to the second power. Alright? And then the next one is 4 times 3 to the third is 27. Y to the third. You distribute this cube to the 3 and the y. Negative 1 to an odd power is negative 1. And then when you multiply 27 times 4, it's 80 plus 28, which is 108. So it's going to be negative 108. Y to the third. And then last but not the least, negative 1 to the 0th power is just 1. 3y to the fourth is 3 to the fourth, y to the fourth. So 3 to the fourth is 81. So 1 times 81, y to the fourth. Okay? Times 1. And then that is simply 81, y to the fourth. Okay? Alright, so let's, if you just add these down, that will be our final answer. So our final answer is going to be 1 minus 12y plus 54y to the second minus 108y to the third plus 81y to the fourth. If you want to write this in standard form, the biggest degree has to come first, so it's going to be 81y to the fourth minus 108y to the third plus 54y squared minus 12y plus 1. Alright? So our answer in this case, let's see which one matches. 81 is option A. Okay, this is one that matches what we have right here. So our answer here is option A. Alright? So there goes the use of the Pascal's triangle to basically expand a binomial. Alright, let's take a look at question 82. It says, how many terms does the expansion of x squared plus 2y to the third to the 20 contain? How many terms does the binomial expansion contain? Alright, remember your Pascal's triangle? The 1 tells you that this is the 0th power. The 0th power has only one term. Okay? How about 1, 1? This is for the first power. The first power has how many terms? It has 1, 2 terms. Okay? And then 1, 2, 1. How many terms does the second power have? This is the second power. You see a pattern here? For the 0th power, you had 1 term. Okay? For the first power, you had 2 terms. From the second power, you have 3 terms. So you notice that the number of terms is always the power plus 1. So if you add 1 to the power, you get the number of terms, right? So 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. So how about the 20th power? Because this one, the power here is 20, right? We're looking at the 20th power because we're raising, for 82, we're raising x squared plus 2y to the third to the 20th power. Alright? So if we're doing that, the 20th power is going to have how many terms? The 20th power is going to have the power plus 1. Okay, if the power is 20, 20 plus 1 is going to be 21. So they're going to be 21 terms. You don't have to do Pascal's triangle all the way there. It's ridiculous, but just follow the pattern. So it's plus 1. So our answer is option B, 21 terms. Okay? All right. So let's go ahead and take a look at question number 83, the last one. So it says, what are the first four terms in the expansion of? So we are not going to expand the whole thing here for 83. We're just going to try and get the first four terms, okay? So we're expanding 83. We're expanding 1 plus 2x to the 6th power. So I'm going to be using the Pascal's triangle. I'm going to go all the way to the 6th row or the 6th power, okay? All right, so we're going to start with power 0 or row 0. This is the first one. Row 1 is 1, 1. Row 2 is 1, 2, 1. Row 3 is 1, 3, 3, 1. Row 4 is 1, 4, 6, 4, 1. Row 5 is 1, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5, 1. And then row 6 is 1, 6, 15, 20, 15, 6, 1. Okay, so we asked for the first four terms. So we're going to be looking at 1, 2, 3, 4. Those are the only ones we're going to extract and expand in this problem. All right, so let's line them up, and then we're going to simplify it. So 1, 6, 15, and 20. Okay, so 1, I'm going to start 1 from the 0th power here, because it looks like that was the order that it's been done. I'm sorry, from the 6th power, 1 to the 6th, and then I'm going to have 2x to the 0th power. If I did the reverse, I will have the 2 to the 6, x to the 6, or basically 64x to the 6 as the first term, but you notice that's not what's happening here. Okay, so 1 will have, the 1 have the highest power, and then 2x have 0. And then a power switch starts. The power of 1, since it has everything, is going to start going down, and the power of 0, since it has nothing, is going to start coming up. Remember, the powers always have to add up to 6, okay, because that's the power that we're aiming for. So we're going to have 1 times 2x to the first. This one is going to go down to 5. This is going to go up to 1. And then 1, this is going to go down to 4. And this will go up to 2. And this one will go down again to 3. And this will go up to 3. So let's check to make sure our work is correct. 6 plus 0 is 6. Good. 5 plus 1 is 6. Good. 4 plus 2 is 6. Good. 3 plus 3 is 6. Alright, so I hope you know how I got all these terms, because I'm working with, in this problem, I'm working with 1 plus 2x to the 6th, right? So 1 is the first term that goes here, and then the plus positive 2x goes into the second parenthesis, and then we just play around with the powers, alright? So that's how I came up with this. Alright, so let's go ahead and now expand that row by row. So for the first one, 2x to the 0 is just 1. So we're going to have 1 times 1 to the 6th, which is 1. 1 times 1 equals 1. Next row, we're going to have 6 times 1 to the 5th is 1 times 2x, which is 12x. And then the next one, 15 times 1 times 2 squared is 4, x squared. 15 times 4 is 60x to the second. All right, let's pause for a second and see if we know what the answer is already. We have 1, all of them have 1, all of them have 12. But in the third term, this has 60x squared. So we can already see that the answer is going to be option D. Okay? Well, let's just finish it up just to show you that it's right. So this one is going to be 20 times 1 times 2 to the third is 8 times x to the third. What is 20 times 8? 160x cubed. All right, so we can see that the first four terms are 1 plus 12x plus 60x squared plus 160x to the third, and that is option letter D. All right, so there you have it. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here. And please post a comment to let me know what you think about this presentation. More clips can be found on mathwayserve.com. Thanks again and have a wonderful day.